Hello students, we are discussing about the transition and inner transition elements. In previous lecture, we have studied all about the electronic configuration and physical properties and periodic traits of the transition elements. Now we are going to discussing, that is, the compounds or complexes formed from transition elements. All of you aware of that transition element shows variable oxidation state and this shows higher oxidation state, that is +7, +8 are the oxidation state shown by the transition elements. Then the element in its higher oxidation state, they forms the complexes, as well as in lower oxidation state they form the simple compounds. Then today we are going to discussing on the compounds or complexes or coordinated compounds of transition elements. Then see here, there are two complexes or two compounds of transition elements. One of them is KMnO4, that is potassium permanganate. All of you aware of that. Potassium permanganate is dark purple color or deep purple color, and one more compound is there, that is potassium dichromate, which is dark orange in color. Now we are going to discussing about first of all, that is of potassium permanganate. Then it is a crystalline in nature, which having luster or having shining, and which is deep purple color. Deep purple color. All of you aware of that potassium permanganate, which is used as a disinfectant and antiseptic, which is used in medicine or it is used in purification of water. Then we will discussing detailed about the potassium permanganate. Then first of all, we have to study about the preparation of potassium permanganate, that is KMnO4. Then see here, the preparation of potassium permanganate, which takes place from ores. Then there are different types of ores which is found in the earth crust. Ore of KMnO4, that is pyrolusite ore. Pyrolusite ore, which is in black color, and black colored powder form, or it is also known as pulverized form, finely divided powder, is used in the chemical laboratory in the detection of qualitative and qualitative analysis of acidic and basic radicals. Then see here, we have to prepare KMnO4 from pyrolusite ore, that is pyrolusite ore having the chemical formula, that is MnO2. Chemical name of that is manganese dioxide. Then preparation of KMnO4 from pyrolusite in chemical laboratory takes place by different methods. First of all, out of that we have to discussing on the chemical oxidation process. Chemical oxidation process of preparation of KMnO4 takes place in the laboratory. Then I am going to discussing with you about chemical oxidation process of preparation of KMnO4. Then see here, KMnO4 is obtained from pyrolusite ore, that is MnO2 powder. First of all, MnO2 powder, which is finely divided powder and which is fused with caustic potash. It is fused with caustic potash and using strong oxidizing agent like KClO3. Strong oxidizing agent like KClO3. Here KClO3, that is potassium chlorate. Potassium chlorate, which is used as a strong oxidizing agent. Fused amount of caustic potash is used to maintain the alkaline nature, and MnO2, that is which is a pyrolusite ore from which we have to prepare the Cheminopod. Then these mixture heated strongly. Heating takes place strongly, and here first K2MnO4, that is potassium manganate. Potassium manganate is obtained, which is dark green in color. In first step, potassium manganate is obtained with the formation of KCl. That means here KCl and H2. Then we have to write this chemical reaction in balanced form. Therefore, thrice MnO2 plus 6 KOH plus KClO3, on heating it gives 3 molecules of K2MnO4, that is which is in dark green color, which is potassium manganate, not the potassium permanganate. In first step, potassium manganate is obtained with KCl and H2. Here in first step, the dark green colored potassium manganate in acidic medium, that means here CO2 plus H2O is used to make the solution acidic. Then it converted it into KMnO4, that is potassium permanganate. It is a potassium permanganate. Potassium permanganate, which is deep purple in color, or MnO2 compound is also formed with formation of potassium hydrogen carbonate or potassium bicarbonate. Then similarly we have to balance the same reaction, that is thrice K2MnO4, 4 CO2 molecules plus H2O, it gives twice KMnO4 plus MnO2 plus 4 molecules of KHCO3. Here from dark green potassium manganate is converted into purple color, deep purple color, nearly it is blackish, deep purple blackish color, potassium permanganate is obtained. That is the chemical oxidation process of preparation of KMnO4. See here in this reaction, K2MnO4, which is green in color, here MnO4 2 minus ion, which is in acidic medium, it may be takes place in neutral medium, acidic or in neutral medium. It converted into MnO4 minus. Focus here, MnO4 2 minus, that is manganate ion, which is converted into permanganate ion. MnO4 minus, that is permanganate ion, that is dark deep green color. MnO4 2 minus ion is converted into MnO4 minus permanganate ion in acidic as well as neutral medium. That is about the preparation of KMnO4 takes place by oxidation process. Then the resultant solution which is obtained here, that is deep purple color solution which is obtained here, it is filtered through the glass wool, or sintered glass is used, and it is evaporated, and crystallization of deep purple color potassium permanganate are obtained here. That is the first preparation method of KMnO4 or potassium permanganate. Then we will discussing on the second one preparation method, that is by electrolytic oxidation. Second one method of preparation of potassium permanganate by electrolytic oxidation or electrolytic process, or it is also just called as electrolysis process. Then see here, in this method, alkaline solution of MnO4 2- ion, that is MnO4 2- ion means it is a solution of potassium manganate. Solution of potassium manganate contains MnO4 2- ions, which is deep blue color, deep green color, which is get electrolyzed. That means here electrolysis of MnO4 2- ions, that means electrolysis of potassium manganate solution in using iron electrode, using iron electrodes. Then at anode, here at anode, MnO4 minus, that is permanganate ion, is liberated. Here that means at anode potassium permanganate is obtained. Then the chemical reaction for this process, that is here twice K2MnO4, which is deep green in color or dark green in color, when it is electrolyzed in aqueous medium, and for oxidation of that potassium manganate, here nascent oxygen is used. Then oxidation takes place at anode. All of you are aware of that. Oxidation is always takes place at anode. Therefore oxidation at anode takes place to converted that K2MnO4 into KMnO4. That is KMnO4 obtained at anode with alkali. That is twice, we have to balance that reaction, twice KMnO4 and twice KH. Here when the solution, deep purple color solution which is obtained at anode, which is get filtered and evaporated, then crystallization of KMnO4 takes place and deep purple color KMnO4 is obtained here. Now we are going to discussing about the chemical properties of KMnO4, that is potassium permanganate. All of you are aware of that KMnO4 is a strong oxidizing agent. It is act as a oxidizing agent in acidic medium as well as neutral medium as well as weak alkaline medium. That means acidic KMnO4, alkaline KMnO4, which is known as Bayer's reagent. All of you studied about that Bayer's reagent. Bayer's reagent is nothing but it is a alkaline KMnO4, which is a strong oxidizing agent, as well as neutral or KMnO4 in aqueous medium or in neutral form. They act as a strong oxidizing agents. They all act as a strong oxidizing agent. Then oxidation takes place in different medium, that is acidic as well as in neutral medium, or it is in alkaline medium. Then first of all we have to discuss the oxidation processes in acidic medium, that is oxidation in acidic medium. Then KMnO4 is strong oxidizing agent. Then oxidation of different compounds or ions takes place. Then we have to discuss about the oxidation of different compounds in their ionic form. Therefore we have to write the chemical reactions in their ionic form. to realize the oxidation of that ion or that compound easily. Therefore, first of all, see here, any iodide solution, that is potassium iodide, or it may be sodium iodide, and that sodium iodide or potassium iodide, which is colorless in nature, which contains I minus ions, that is, which contains I minus ions, which is get oxidized due to the Cheminopod. That means Cheminopod contains MnO4 minus ions, that is permanganate ion, and that permanganate ion, which is purple in color. I minus ions present in the solution of their compound, which is colorless. And here, because of potassium permanganate or MnO4 minus ion, I minus ion get oxidized, but this takes place in acidic medium. Therefore, here acidic medium, all of you are aware of that acidic medium, that is H plus, which is from dilute HCl or dilute H2s sulfur. Acidic medium is maintained here, which get converted into here I minus get converted into I2 solution, that is iodine solution, and MnO4 minus, that is permanganate ion, is converted into Mn2 plus ion, which is converted into Mn2 plus ion. Then we have to balance this reaction. Therefore, twice MnO4 minus plus 10 molecules of I minus ions plus 16 H plus ions, which makes the solution acidic. Because of that, solution becomes acidic. It converted into Mn2 plus ions, that is Mn2 plus ions, and iodine, molecular iodine is obtained, which is brown in color, with 8 molecules of H2. Then see here, in this reaction, I minus, that is iodide ion is converted into I2 molecular form, that is iodine molecular form. That means here -1 oxidation state of iodine is converted into, in molecular form it is 0. That means here oxidation number of iodine increases. -1 to 0 means it increases. That means here I minus ion undergoes oxidation. That means oxidation of iodide ion takes place into iodine, and oxidation of that I minus ion is because of MnO4, that is permanganate ion. And permanganate ion, here see here, permanganate ion consists of, or it possesses, Mn plus 7 oxidation state. Here Mn is in plus 7 oxidation state, which is converted into Mn2 plus oxidation state. Mn2 plus. That means here oxidation state of manganese decreases, and oxidation state of iodine or iodine increases. That means I minus ion undergoes oxidation, while MnO4 minus ion undergoes reduction. All of you aware of that oxidizing agent itself undergoes reduction, and it oxidizes to another compound or ion or elements. That means here colorless solution changes to brown color. Therefore, I minus ion, iodide ion, is oxidized due to the permanganate ion into iodine solution or iodine. That is the oxidation of iodide ion. Then similarly, MnO4 minus ion, that means potassium permanganate, it also oxidizes to the Fe2 plus ion into Fe3 plus ion. Fe2 plus ion, which is present in all ferrous compounds, ferrous chloride, ferrous sulfate, which is faint green in color. That means Fe2 plus ion which is ferrous ion, which is oxidized, ferrous ion which is oxidized due to the MnO4 minus ion, that is permanganate ion, which oxidizes to Fe2 plus ion, Fe2 plus ion, ferrous ion. And this process, oxidation of Fe2 plus ion, takes place in acidic medium, that is 8H plus, which is converted Fe2 plus into Fe3 plus. Fe3 plus means it is a ferric ion. It is a ferric ion, and MnO4 minus ion, permanganate ion, is converted into Mn2 plus ions. It is converted into Mn2 plus ions. Then we have to write the same reaction in balanced form. Therefore, MnO4 minus plus Fe2 plus ion, that is 5 molecules of Fe2 plus ion, that is ferrous ion. In acidic medium, it converted into Fe3 plus ion. And here, Mn2 plus ion, which is obtained due to the reduction of MnO4 minus ion, that is potassium permanganate ion, undergoes reduction and it converted it into Mn2 plus ion with 4H2. That means here Fe2 plus ion converted into Fe3 plus ion. That means here oxidation state of iron increases. That means it undergoes oxidation, while at the same time potassium permanganate, which undergoes reduction. Therefore, potassium permanganate is a strong oxidizing agent in acidic medium, as well as it oxidizes to the H2s. That means here the next reaction, oxidation of H2s. All of you are aware of that H2s in acidic in nature. Therefore, it get dissociated in aqueous medium into H plus S2 minus ions. And the dissociated ions, that is S2 minus ion, which is of H2S aqueous solution. Then MnO4 minus ion, that is permanganate ion, which is oxidizes to S2 minus, that is sulfide ion, which is sulfide ion of H2S solution, isn't it? Then it oxidizes in acidic medium. Therefore, 6H plus, it gives it into S2 minus ion, is converted into its molecular form. That means colloidal sulfur is obtained here. Colloidal solutions, all of you are aware of that. In 11th standard, all of you studied about the colloidal solutions and colloids in the 11th standard. Therefore, here colloidal sulfur is obtained. That sulfur is in its molecular form with the conversion of MnO4 minus ion, that is permanganate ion, into Mn2 plus ion. Then we have to write the same reaction in balanced form. Therefore, twice MnO4 minus 5 molecules of S2 minus ion. It requires about 16 H plus ions to convert it into twice Mn2 plus 5 colloidal sulfur elemental form or molecular form is obtained in this solution with 8 molecules of H2. Then see here, S2 minus is converted into sulfur, colloidal sulfur. Here -2 oxidation state of sulfur converted into having the oxidation state 0. That means here oxidation state increases. That means sulfide ion undergoes oxidation. It is due to the potassium permanganate ion, and potassium permanganate undergoes reduction. Therefore, here MnO4 minus potassium permanganate ion act as a strong oxidizing agent. Similarly, we have to discuss the oxidation of oxalic acid. oxidation of oxalic acid also takes place by using potassium permanganate. We see here potassium permanganate, that is KMnO4, which contains MnO4 manganate ion, which oxidizes to oxalic acid, that is having chemical formula H2C2O4. We have to write this in as well as this form, COOH-COH, that is the oxalic acid. That oxalic acid in acidic medium, it converted into CO2 plus that H2O, and MnO4 minus ion is converted into Mn2 plus ion, isn't it? Then see here, oxalic acid which liberates CO2 from it. That means hydrogen are removed from it. That means removal of hydrogen from oxalic acid is also called as oxidation, isn't it? That means here oxidation of oxalic acid takes place due to potassium permanganate. Then we have to write the same reaction in balanced form. Therefore twice MnO4, it liberates the 10 molecules of CO2, that is carbon dioxide, which here 5 molecules of H2C2O4 is used in acidic medium, that is 6 H plus ions, which gives thrice H2O and Mn2 plus ion. That means in this reaction oxalic acid undergoes oxidation due to the potassium permanganate in acidic medium. Now we are discussing on the oxidation reactions of KMnO4 at neutral or weakly alkaline medium. Then oxidation of I minus ion, that is in iodide ion, I minus ions, that is iodide ions present in the solution, which is get oxidized due to the potassium permanganate, which contains MnO4 minus, that is permanganate ion, which oxidizes to the iodide ion in neutral medium. In this process MnO4 minus, that is permanganate ion, iodide oxidizes to the I minus ions in neutral medium, and it converted it into IO3 minus. That means here in IO3 minus ion, iodine has oxidation state, that is +5. That means here I minus ion is converted into I +5 ion, that is here -1 oxidation state to +5 oxidation state of iodine. That means oxidation state of iodine increases. It indicates that I minus ion, that is iodide ion, undergoes oxidation due to the MnO4 minus ion, that is potassium permanganate in neutral medium. Then we have to write this reaction in balanced form. Therefore twice MnO4 minus iodide ion present in the solution, that is I minus, plus H2O, it gives IO3 minus plus OH minus ions, which is obtained here, and MnO2, that is twice MnO2 and twice OH minus ion. Here MnO4 minus, that is potassium permanganate, is act as a oxidizing agent in neutral medium. Similarly, we have to discussing on the oxidation of thiosulfate ions to sulfate ions. KMnO4, in this reaction KMnO4, that which contains MnO4 minus ion, which oxidizes thiosulfate ions. Thiosulfate ion, that is S2O3 2 minus ion, which is a thiosulfate ion in neutral medium. In neutral medium, it converted into sulfate ion, that is SO4 2 minus ion, and with it twice OH minus and MnO2 formation takes place. In this process, permanganate ion oxidizes to thiosulfate ion. Thiosulfate ion in neutral medium to sulfate ions. Then we have to balance this reaction. Therefore, here 8 molecules of MnO4, it oxidizes to 3 molecules of thiosulfate ions. It gives 8 molecules of MnO2 and 6 molecules of SO4 2 minus and twice OH minus ion. Then one more oxidation reaction we have to discussing here. The oxidation of manganese salt to MnO2 compound takes place due to the permanganate ion also. See here, oxidation of manganese salt which containing Mn2 plus ions, which is oxidized by MnO4 minus ions. Permanganate ion oxidizes to Mn2 plus ion, which is present in manganese salt. It oxidizes in neutral medium and converted it into MnO2. Then we have to balance this. MnO4 minus, that is twice MnO4 minus, thrice Mn2 plus and twice H2. It gives MnO2, that is 5 MnO2 plus 4H plus ions. See here, manganese salt which containing Mn2 plus ion, which is get oxidized due to the permanganate ion present in the potassium permanganate in neutral medium. It gives converted it into MnO2 compound with liberation of 4H plus ions. That means here Mn2 plus ion is converted it into Mn4 plus ion. That means it converted it into Mn4 plus ions. That is, oxidation number of manganese increases. Therefore, Mn2 plus ion undergoes oxidation due to the permanganate ion. That is about the oxidation process of different compounds or ions. It is due to the potassium permanganate. These all reaction indicates that Cheminopod act as a oxidizing agent in aqueous medium, that is in neutral medium, or it is in acidic medium as well as alkaline medium. Then we will discussing about the uses of Cheminopod, that is uses of potassium permanganate. All of you aware of that potassium permanganate is used pains when there is pains in teeth. Then it is used as a disinfectant or it is used as a antiseptic. And as it is a disinfectant, it is used in the purification of water. It is also used in the unsaturation test in the chemical laboratory. Cheminopod, it is used in the volumetric analysis of different types of reducing agent. Then it is also used as a detection of halide ions in qualitative analysis of acidic radicals and basic radicals. All of you aware of that Cheminopod is a strong oxidizing agent. That means it acts as an oxidizing agent in laboratory in different types of oxidation processes. That is about the potassium permanganate. Thank you.